Hi, Brett from Liquid Freedom Brewing. Um, Today we are going to be building a boil controller. Going to be converting the brewery from propane to electric and need a way to control power on a heating element. And so what I'm going to be doing is building a controller to regulate the power going to the heating element. So there's a few different ways you can manage that. I've gone with this power regulator. So basically, it allows me to dial the percentage of power that's going to go to my element so that I can maintain a nice rolling boil that I want. But when I'm trying to get it up to temp, I can run it at 100% to get it to temp, to a boil, and then regulate it back a little bit so that I can manage to just have that nice steady rolling boil that we always look for when we're brewing. Okay. So that's what this is going to be, and we'll go into it a little bit more as we go through the build process. Power coming into the box is going to be regulated, so I've got some bus bar terminal bars here to manage power coming in and then being distributed out to where it needs to go. The regulator, which will regulate the power to the 220 volt outlet. So we're using 220 volts power here, so we're going to be using a 4500 watt sling blade heating element is what I have planned for my kettle. So that's the setup here. Couple of power switches on here. One is going to be master power for the box altogether. One will be power to the element to allow the element to actually run. And then one will be for a pump. I'm going to have the pump power controlled here as well for the brewing pump. After that, we have a device here which is going to allow us to manage the actual amperage, or not manage, but view what amperage is being sent. So this is a volt amp meter compatible with 220 volt. But this will tell us how much AC power is going and then how much amperage is going to the element. Uses this donut to measure the amperage. And then, not necessary, but I wanted to add a thermometer. So I've got a thermocouple here, which will be mounted inside the kettle. So that'll be mounted to the kettle with a bung on there, bulkhead. And then it'll tell us what temperature our water's at. I imagine I'm mostly going to use this for as I'm bringing it up to a boil, I'll just kind of know where I'm at. And until I get a second kettle and a Herms coil and everything to build an actual Herms side of this, this is going to be my kettle for heating strike water and sparge water. So I want to have a thermometer in there so that I can know where it's at. I'll still use a stick thermometer as well just to make sure everything is aligned, but this will give me a good idea right on the box. Finally is the box. So pretty small box here, not really large. It's enough to manage boil controller. It would not be enough to really manage boil and the Herms kettle as well. But that's not what I'm going for right now. I just want to be able to manage my boil. So what I've done is gotten a little bit smaller box, but it is large enough to fit everything in here. So that's where we're going to start from. So as we start working on these, one of the big things is to make sure, obviously, that you have enough space for everything. And one thing to do with that, and I'm going to move a couple of these pieces out of the way. Switches. Regulator. So one of the things to do is to actually get your box and kind of decide how you're going to lay it out. So what I've kind of done is figured that I'm going to have my my regulator here and then my terminal blocks on this side. Mostly just because that's the way that it worked out for me best. One thing that I did also was said, okay, what are my items that are going to be above this regulator? Because this is the tallest item inside the box, and it's going to be my switches. So my switches are going to go right here. So by simply placing them on here and then still confirming that I can actually close the box tight, right? There's no gap here. So I can close the box tight. So that tells me that my switch can be over this. And there's even a little bit of space there, and plus the thickness of the cover, which isn't much, but all of that together tells me that I can put these switches up here if I want. Not a big deal, okay? So when all is said and done, right, my box will be laid out with the controller and the displays for amps and temperature and everything, as well as switches, and everything's going to fit, okay? That was the other thing that I wanted to do, was make sure that I had a layout that I liked. So what I had done was I took this box, it's just a plastic box, and I put tape on it, you know, good old blue painter's tape. Drew that out there so that I could draw and figure out and make mistakes and erase and do everything else. So what I actually landed on was that I'm going to have a master power switch, right? I'm going to have an input. This is going to be the input for the thermocoupler. So this will be where my temperature reading comes in. So that'll sit there. The temperature display itself will be next, right? So that's going to sit here. And then I'm going to have my additional switches for my element and my pump, okay? So that laid out very nice and neat, okay? On the top here, I'm going to have my regulator, right? So my controls for my regulator here. And then my volt amp display is going to be here. So again, it's a fairly small box, but laying it out in this fashion, everything fits. There's a few different layouts that I tried. I think this is going to work best. Kind of isolates my master power from my accessory power. So it will prevent me from mistakenly cutting power to the box or thinking that I'm turning on the box when I'm turning on an element, things like that. So very simple, but just logic for the workflow. And then my control will be here, so I'll flip the power on and then I'll adjust my power setting, right? 0 to 100%. So pretty straightforward, but it was nice to put this tape down. Like I said, I drew it all out. You can see by looking at the box cover here, all the different components are kind of penciled out on the tape. And then if I had wanted to make a big change, I could have just torn the tape off and not left a bunch of marks on the box that I had to decipher, right? So that's what that is. Now, in addition to all of these components, obviously we need wire, right? So good old trip up to the local hardware store and picked up some wire. So we're doing 220 volt. The element that we're going to use has a potential for about 20.4-ish amps. So we went with a 10 gauge wire, which is sufficient. Really, I could run up to pretty much run up to like a 5,500 watt element if I really wanted to. But I wanted to make sure that I didn't have to deal with that if I decided to get a bigger element in the future. But got a couple different colors of wire here so that as I'm running wires inside the box, can keep everything kind of organized and understood, right? Obviously, we're going to run green for ground, right? Most common method to run green for ground. But we're bringing in 2 hots and a neutral. So we've got the full 4-prong box coming in here. So I've got a couple different colors here so that I can understand my hots and my neutrals. I've got the ground, and that's it. Additionally, we've got the power cord for the wall. Okay, so this is a 10-3. Yes, 10-3. So it's got 3 conductors plus a ground wire in here, and this is also 10 gauge, just like that. So it's going to be able to carry that load. We should never come close to hitting this max voltage or max amperage, really, of what can go through here. But everything really is just kind of geared towards, I don't want to run a risk of frying anything out because I'm using too small of a wire. Likewise, all the switches that I used are good for 30 amps. So I've got 30 amp switches that I'm using. And then the power regulator and everything is good for 30 amps. An interesting thing with this power regulator actually is that it's really inexpensive. I think this is only about $18 or $20. The regulator is capable of managing 5,500 watts, I believe it was, but they only want you to be able to do 50, or only recommend that you do 5,500 watts for a short period of time, not a long-term thing. So when you're looking at these, there's a lot of different ones out there. This has the digital, percentage adjustment. A lot of them just have a little potentiometer dial on them. Any of those work, but just when you're looking for something like this, just make sure you're looking for what their continuous load capacity is, because the max load capacity on this was higher than its continuous load. So I made sure of that, and it's one of the reasons I'm able to go with this is I'm using a 4,500 watt element, not a 5,500 watt element. So even during my ramp up to bring to a boil, I don't have to be concerned about this getting burnt out. Okay. So that was the power regulator and everything that we're doing here. Again, very important to make sure that you lay out your box in a way that makes sense for you, but also so that when you put the cover on, everything still actually fits. If you don't think ahead to that, you might lay some things out and mount some things in the box or the lid and find out that it doesn't work, and you gotta start over, get a new box, which again aren't very expensive, but it's still a hassle. You gotta wait for the new box and everything else. One of the reasons that I'm doing all of this is about cost savings. So all in all, I haven't spent a whole lot of money here. I'll put like a breakdown of the cost in the description. But to buy one of these, when I was looking around, I was looking in the neighborhood of $350 or so. So with all of that, what we'll do is we'll go ahead and cut this box out. We're going to go ahead and drill holes in the spots for all the different components. And then I've got a saw that I'll use to kind of clean all the edges up and make everything nice and neat. We'll kind of interested in how it's going to work on these smaller ones. My blade's a little bit bigger than that, so I might have to get a little fancy with a knife or something along those lines, but we'll get that all squared away. Okay, so I wanted to just pause here and just kind of show you the box as we go through. You can see it's just a bunch of holes that I've drilled in it. And the idea, of course, is to draw out where your components are all going to go. Measuring the actual fit of the component and not the face of the component. So it's something I didn't mention, just as a reminder, right? I don't want to cut out this size. I want to cut out this size in here, right? You can see it's much smaller what has to go through the box, right? So when I draw my lines, right, you can see those lines are a lot smaller than what this face of this is. So just a little reminder there. Drill the holes, and then you can get your skill saw blade in and actually saw along the lines. So just wanted to pause and kind of show you that midstream. Okay, so here we are. So all the spots are cut out for the various components. Started with the drill, and then actually used a saw here. I didn't have my skill saw, so I had to do a little bit creativeness here. But I used a saw, and then I actually used, because it's plastic, I was able to just use a utility knife, razor knife here, to do the fine adjustments. If I was graded on the precision of my cuts, I'd probably get a pretty poor grade. But what we have is a box that will fit all the components. So as we go through, right, I'm not going to push them in because they kind of all have a clip of some sort to hold them in, and I want to get the tape out of there. But as we look through this, right, all of the components will now fit into the panel, right? And once they're all in the panel, then we are good to start wiring. So wiring these things is really the kind of the hardest and the most important part that you want to do right, because you want to make sure that the power and everything is flowing in the correct way. You have enough room. This box, I haven't purchased one. Some people recommend using a fan in these boxes. So I may put a fan in here. I'll have 12 volts to give power to this temperature meter. So I'll have 12 volts available. So I may put a fan in there, a 12 volt fan. Haven't decided yet, but as soon as I get that all figured out, I'll do that. But the next step on this is to kind of peel all this tape off, get all these pieces put in here. This one actually screws in. It's the only one here that doesn't have clips around it. Most of these components have some sort of clip that kind of just tension holds everything in place. Depending on how they actually sit and are tight in there, I may put a little drop of super glue on these to help just give them a little more support so they don't move around, especially when I'm looking at something like the switches, which I'm going to be hitting. I want to make sure that they're firmly held in place. And then this I won't be hitting, but this is going to be, I put a connector here for the thermocoupler so that I can kind of disconnect that. So this, again, I want to make sure that this is nice and tight because it's going to have some level of force placed upon it. So like I said, the next step is to get all this tape off of here, get all these components actually clipped in place, and then we'll start wiring. So we'll be back. Okay, so here we have it. So got all my switches, again, master power. We'll have an element on off just to make sure that I don't make a mistake and have a dry fire of the element. And then I'll have one here for the pump. Temperature probe meter for amp, and then the actual temperature probe and temperature display. This guy right here, I neglected to realize that it did not come with any kind of screws. So I need to pick up a few screws. I don't have anything handy that's going to work for that. So, but this is what the front panel will look like. So it's going to just kind of hold that sticker on there now. This will be the setup, and then as soon as I get everything wired, we'll be able to go on to the next step and actually test this thing out. But so that's kind of the first piece of it here. I'm going to get this wired up, and then we'll probably come back and finish the recording, showing you the wiring of that. So, all right, here we go. Jump forward a few hours later. Not only do we have the box, picked up the screws so that I can connect that panel to the box, leaving the sticker off until everything is 100% done, tested, and then I will put this on. That way, just in case for whatever reason I need to unbolt this, I can. Inside of the cover itself, I've gone ahead and connected the bulkhead fitting here, the panel fitting here that I made, or installed rather, for the thermal probe. All right, so I've got my thermocoupler that'll plug into this on the outside, and then in the back I've got that wired over to the input for the temperature display. Notice all the switches here are here, and I've got switches here. I put these switches on here, one, to keep the wires where they need to be and kind of test fit it. but also I'm able to turn the switches, and using a multimeter. If you don't have one, you should definitely invest in one of those if you're going to be messing with this electricity. And I was able to use the multimeter to confirm my continuity between everything. I can test continuity all the way up to the pulse width modulator here, and then I can test it from there out. So obviously with no power running to this, the circuits aren't closed, and therefore I can't test continuity through it. But like I said, I can test it from power entry to there, and from there out to the element. Additionally, I've wired this up. This switch is up for the 120 volt outlet that I'm going to have for the pump outlet. That pump outlet will go on this side. That'll go in here. So I just need to run the short wires from this switch so that I can turn the pump on and off to that outlet. That outlet will be on the side here. One thing I didn't show before was the outlet for the heating element. So made a extension cord here. It's L620, L630. L630 plug. So it's 3 connectors, 2 hot lines, and a ground. So this is the exact connection that is on the heating element that I'm going to be using, which, as I mentioned before, is a sling blade. So it has an L630 connector on it here. TC clamp, tri-clamp connector is how it's going to go into the kettle. That'll be another build that I show you guys. But that power cord will go from the heating element here to this box, and then that'll be heating the element, obviously, powering the element. So the other piece that I have here, so this is the connector, this is the compression connector for the feed wire coming into this. Just need to pick that up and then feed all the wire inside. So one thing that you'll notice in here, I ended up with 3 terminal blocks. So I've got a hot here and a hot down here. So those are my 220 volt, 120 each leg. The top block is also going to power the switch and the pump, as well as the transformer for the temperature display. So I'm pulling both my 120 volt options off of that top block. Block down here, this is for my neutral. So this is for the neutral line for that 120 volt outlet, as well as the transformer. So all that's in there. One of the pieces kind of hanging out in here is the toroid for the amp meter. So I haven't connected that yet. I'll connect that when it's time to put everything in the box. But other than that, everything's there. So almost done. Almost done with this. But so finished the box. So inside the box is all wired up. Received my 110 volt outlet and the 12 volt transformer this morning. So received those, so was able to finish the wiring. Pulled all my temporary switches out. The real switches are all hooked up now. Temperature sensor, voltage, amps, everything's there. So what we have now is a fully functional system. Couple of things that I also had to do in the meantime was actually bring power over here so that I can actually power this box up. We were repurposing a 30 amp outlet that was on the other side of my basement. We're repurposing that, bringing it to this side of the basement to run power for the brewery. Now, it's not all in place, final place yet, but I wanted to validate this box real quick, and then I'll get this mounted up in the wall over here, and then we'll be good to go. So, like I said, I did put the label on here for the power regulator. Heads of this. So let me go ahead and power this thing up. And you will see, and this is upside down for you, but you will see as soon as I plug this thing in, we get light. So, so what we have here is we have one light on the main power switch. So if you remember, I put a main power switch so that I can cut power to the entire box if I want to. The other two switches, this will be for the element, which I'm going to label down here, and then this will be for the 110 volt pump outlet for the pump. So I can control the pump from this box as well. And again, if everything is on and I want to just kill everything at once, I can just hit this main switch. The other piece that's here, let me go ahead and plug this guy in. So this is the thermocoupler. All right, so this will actually be screwed into, this part will screw into the kettle, and then I'll be able to connect and disconnect as needed, so that I can kind of keep this nice and neat, as well as the kettle and everything else. When I turn this on, you're going to see a couple of things. So one, obviously, power regulator lights up. We've got voltage and amperage meter lights up, and this switch lights up. So that is lit up because it's actually receiving power. I had this set at 50%. As I turn this down, I don't know if you can notice it's getting a little bit dimmer, but as soon as I get down to almost zero, you see the volts have dropped considerably here. I'm surprised it didn't go to zero, but the light is also very dim. So there's a little bit of power bleeding through, but not much. Now the amps are registering zero the whole time because there's no actual draw on this. Until I plug in my heater element, which interesting is on this side. Once I plug in my heater element, then you'll see the amperage go up and down. I don't have that mounted in the keg, or the kettle just yet, but as soon as I do, I'll be able to see that. Now, cut the power, everything's going to go out. You'll see here with the probe, temperature's rising because I'm squeezing it here. I did have two wires here backwards, so when I did this the first time, the temperature actually dropped. So it just meant I had the polarity reversed. Polarity is important on your thermocouplers, so just had to flip that around. Unplug that just so I don't get in trouble, don't need it right now. And then the 110 outlet here on the side, it's on now. Right now it's off. Now, one thing that I'll show you here is the switch for the outlet. So if I take my multimeter here, all right, and I'm going to set this thing on the 600 volt, right, and I'll bring this regulator back up, the pulse width modulator. We can see, you should be able to see in this display right here, I can get the probes in there just right. Switch is off, so there's nothing there. As soon as I turn that switch on, we can see voltage start to register. So right there I've got 245.6, right? And then if I look at my meter on the box here, 243. So a slight difference in the reading between the two. Doesn't overly concern me. It's a fairly inexpensive meter and definitely an inexpensive meter here. But the main point is I'm at 243 right there. So there's my 246, and when I turn my switch off, it drops to practically zero. Now, there always reads a little bit, and I'm not an electrician by any stretch of the imagination, so I don't know exactly why that is. But even in my outlet, when I had turned off my breaker and then I used this to confirm that the correct breaker was turned off, I still read a small amount of electricity. So it doesn't concern me, but that's it. that's the whole build. Couple things that if I had to do this again that I would do differently. First off, I would use a bigger box. There's enough room in this box to do all this. It is tight though, and it, because of how tight it is, was one of the reasons it took me a little longer to build this box than I had hoped. But overall, wasn't bad. The other thing that I would do is get a box with a bottom panel in it. So this box is just a bare bottom. It's got some nubs and stuff on there that I could screw stuff to, none of which lined up correctly for me. So I've got my screws here, here, and here for my terminal bars. And then here is the screws for the pulse width with modulator. I would have preferred to use a plate that everything could mount to, and then that way this box would be smooth on the outside. It's just an aesthetics thing. I don't plan to be moving this around or anything. One thing I may do is I may actually use a couple of these screws to put a little bit of a hanger on there so I can kind of hang it on the wall. We'll see what I decide to do there. But you can see that here's the box. Got the thermocoupler that's going to go with it, right? And then this is the power cord that'll go from the box to the heating element. So I've got all my piece parts here now, so that the next step is to actually mount this heater element in the boil kettle, and then I can start testing with water. But thanks for watching. If you like what you're seeing, give me a like, give me a subscribe down at the bottom there, and if you have any questions, put them in the comments, and we'll see what we can do. Happy brewing, everybody.